Okay, let's continue this part. Is the promise as a functor. I want to say that by comparison to the ES6 promise, what is wrong with ES6 promise? Let me increase my coding here. All right. Okay. What is up?
很近啊，
有快的。
想着说呀。
Okay, I'll just write here promise. Okay, it's a functor. First, there's two problems with ES6 promise. One is when you call is a new promise, let's say 1, that resolved to 1 instantly, right? Is it? Or something like that. So when you construct a promise, whatever, let's say, because this is synchronous, it's just a value. What if you go to a network and generating a promise? That network activity already happened, correct? If you get a promise, something is already running to fetch something or go perform a side effect. It's already running. That's problem one. Why that's a problem? Because if you have, let's say the opposite, if it's not running, you get a promise, and you manually trigger it to run the moment you think it should be run, then you can compose all the promise you want, create branch or whatever in your code. In the end, you only run the promise you need them to run. Let's say you have the if-else, which give you different promise. If you have this promise running already when you give this promise, the if-else does not have any effect. This promise already run, right? Already go to network, fetch data or whatever. So in your control flow, you have no way to say, hey, give me this bunch of promises, and then I can pick which one to run. I don't have that capability in ES6 promise. The second problem is this then method. Brackets are here, I couldn't remember. And you put a function, right? The then is a very good one, but the problem with it is, do you know the type signature for the then function here? The then method? No? Let me just, yeah, sorry?
What do you mean?
The type signature for that.
So
It's a method, right? So, because let's denote it with a syntax like functor, fa and a to b, that's the f, right? And then give me fb, right? This f is promise. It's similar, like it's exactly the same like any functor, the map function, right? But what if this f here, a to b, give me a to fb? I'll produce another promise as a return value for this then method. It still give me fb, right? It doesn't give me ffb. Correct? We all understand that, right? It doesn't, it collects that automatically for you. So that's not the definition of map. So this then method actually mixes in the notion of monad, like next time we're going to talk about it, but it's quite dynamic. So that's the second problem, because in composition, you need to know the type exactly. You can't just have this dynamic part in there. So to solve these two problems, we have the Fantasyland promise. Let us examine that. Okay, so the promise in week 2. Well, first, this is a very simple version to explore the a value in future in functional programming. The Flutter.js is a better alternative when you actually use it. A purely functional implementation, much better implementation. Yeah. So this is just for this lesson's purpose. Yeah. I will use Daggy. So this class is called promise, and then it has one parameter to construct it called fork. Fork itself is a function. So when you construct a promise, you pass a function in. And what kind of function? The function that receive resolve as its parameter. So the fork here, when you construct, let me demonstrate. You pass a fork to construct a promise. And this fork equals to a function like this. And you need to call it with some value, like the ES. When you do ES6 promise, right? You give it a function. The first one is resolve. The second parameter is reject. And you perform side effects or asynchronous operation. You call resolve or reject based on the value you have, right? So, but here it's only resolve. There's no reject. There's only one callback you get for this fork function. Now that means you can do, fetch, some URL, right? .com, and you do then resolve. You can do this, catch, resolve. So would it it only give you resolve, it doesn't have reject. Of course, this is very lousy implementation of it, but that's all you got out of the fork function. It is a functor as well. Let's examine the definition of it. What it does is it forks itself first, so it runs the promise, getting a value out. So this A is whatever you resolve to. So for example, data is that data, basically. Right, it's A passing. And this A data, and transform that using F, and resolve again using new promise. All we can do this is essentially the same. Right? So this is the first time we pass a function to as a constructor parameter. Because maybe either we pass the value itself, right? Here we pass a function in, which takes a callback again as the parameter. So it's very similar to ES6 promise. The difference is the resolve here. It doesn't have reject. Let me bring that to. So how do you use this map? Now I have this P here. I can do P.map to deal with the data comes in and do something about it. The value produced is still a promise. It's like the then. It's like the then here, but we call it map because it's a functor. We can't call it then. Yeah, that's the consistency of interface for functional programming. You just cannot call it then. It doesn't make sense. I think maybe all the function languages, it enforces you to. There's a language construct enforces you to use map actually. So that I can call it functor. That's basically it. That's the promise implementation. we need to, because we deal with ES6 promise all the time, so we need to convert ES6 promise to this promise if we want to use it, right? So I give a like implementation like this, but it's really naive. What's the problem with this is when something goes wrong, you basically get error from the resolve, right? You map again, you get error, not the data. Okay, so what do we do here is actually use what we already learned. Another version of this would be this. Okay. This is in week 2's folder. So fetch JSON, what does it do? This P, capital P here is just that promise we define here. Let me just get rid of this. Just the promise defined here. As a constructor, it takes a fork function. The fork function only has one parameter, resolve. Yeah. What it does is fetch using the URL passed in. Here it becomes ES6, right? So that's the conversion happens. Because fetch gives you ES6 promise. Because then the response, I'm checking if the response larger than 399. If that's the case, that's an error, right? And third out that error. Otherwise, I return response.json. That's all just standard stuff when every day you do this in fetching stuff, right? And then here, this scenario, the if error scenario will not go here. Because of third error here, it will come here, right? So this part is always gonna have this value. Yeah. I construct either right for that. And then I call resolve with that value, with the either right. And the catch part is either left. And the either left value being passed to resolve. It means when I do fetch JSON, this is getting a bunch of Pokemons.
Location?
Sorry? Yeah. Let me just get rid of this. Yeah. Hopefully the network works. When I do map, I want to lock this map. Let's see what's going to happen. Let me change that back to this file. Into maybe my network doesn't work. URL. Okay. Wait a second. Scrap.js. Yeah. Let me see what kind of response I have here. Hopefully network is okay. So is the URL correct? Maybe
there's another return. You need to in your promise implementation in the promise.js.
Oh, sorry.
You only return once.
Sorry. Yeah, I know what's going on. I need to, because that's exactly my point. It doesn't run. Yeah. You call this function give you promise, but it doesn't run. You need to call the fork, right? It's like, yeah. Let me get rid of that. Fork will give you the value in the end. Yeah, that's the request response body basically. Now I can map it, right? So you see how I map it before, but it doesn't really let's say prop status. Without fork, it doesn't run, right? It doesn't really run because it returns it finished instantly because the network takes time. If I fork it, it runs. So when I get this promise, it hasn't go to the network fetch anything. Right? You can get this promise, and then you basically can write a function, receive the promise, and then you do some if-else condition, and then say, now I return you a mapped of this promise, or I just discard that promise at all and certain condition. This promise doesn't run, and then because you return, maybe you will return a maybe promise here, and then some other program in the end will get or else dot fork. Right? So only the last bit of your program should run your promise, basically. Because that's performance side effects. So you can construct a program and doesn't have, worry about is it network happened yet or not. You just map it and continue transform the data as if it has been run. And in the end, you fork it. If you don't fork it, it's not wrong. Yeah, so that's basically the conversion between, well, it's a utility function on the fetch function, and to convert to a Fantasyland promise. Yeah. We got. Do you guys want to continue this, or I can introduce another concept and then we go through examples next week, or we just stop here? Oh, cool.
What's the next concept?
Applicative. Maybe we go through that a little bit.
Yeah.
Okay, let me use my board. So to write down the name first. Yeah. Basically, all the things here are applicative. Applicative needs to be a functor first. But not every functor is applicative. I can't think about an example, but that's the order. Right? Applicative must be a functor first. What does applicative do? Let me give you an example using ramdoves, a utility function called AP. Ramda has this function. What it does is, we construct it by so the difference here is, say, I have a function inside a functor, right? And I have the same functor with a value. Yeah?
Mm-hmm.
And then the AP function will apply that function in the functor with the value in the same functor, give me the result in that same functor. When you look at AP's signature type, you will see a very close resemblance to map. So this is let's be general here. First, it's a functor, right? A to B. It's a function, right? A functor contains a function. The second parameter it takes is a functor of what? A or B? A, yeah. Because the value here will be passed into this function and produce another value. So whatever here, the value here, the type for it, needs to be same type here. So it will be FA here. It will produce FB. Now, we have iterated this many times. Map is A to B, FA to FB. Yeah? The only difference, the bracket is wrong. The only difference is there's F here. What's the difference here? Yeah? So if you have a function inside a functor, how do you now apply it is by this function. Now why? Why this is useful? Why the hell you put a function inside a functor? Let me convince you. Let's say you have a function is this kind of a takes 3 parameters. Let's call it add again. Now I have an array 1, 2. I don't need all those parameters. Maybe A plus B, that's enough. Yeah. I have another function called add1 equals to add with 1. Yeah, that's easy enough. I have an array called with numbers inside, 1 and 2. In order to transform that to 2 or 3, it's very easy, right? So map add 1 and then the array here. Easy. Now how do I to say I have that array, I have another array 2 and 3. Sorry, very easy, like just one element. I want to add 2 to 1. I want to add 2 to 2. How do I do that? I can map. Maps looks like a very, very promising solution here. I say, because I have add here, it takes 2 parameters, right? 2 parameters. A map, like 1, 2 first. What does that give me? That give me A to A plus 1 and A to A plus 2, right? 2 functions, yeah? Mm-hmm. And then I can do what? Then it will produce the result I want. I want 3 and 4 here. In a way that you can go arbitrary level, right? A, B, C, D, E, F, G. Map doesn't give you a capability of that. In a way, apply is the extension of map. So you can work with functions with more parameters. It's for currying under a functor. So you query with normal values, just call them 1 by 1. what if all those parameters are under a functor? Then you have to using the ability of applictive to do that. So that's basically the concept and the example for applictive. We'll go through some other things next week about that. Yeah. Yeah, cool. Yeah, thanks.